if we can transfer all the knowledge that we have from commercial airliners, from traditional helicopters over to eVTOLs in terms of safety to the customer, so that grandma can fly to Thanksgiving with her grandchild in the urban air environment and doesn't even think twice about, is this really safe because it's brand new? That's where we want to go as an industry. And I think that is also one of the other motivations that have talked about with our collaboration. If you get everything up front, all the simulation, you can do all the fault and failure modes up front in the simulation. You can actually learn very quickly about your system and fit into this safety environment.
Hello and welcome to the GT Tech podcast. I'm your host Lalit, and in today's episode we are going to talk about the aerospace industry, and we'll be diving deep into a fascinating topic of eVTOLs, electric vertical takeoff and landing vehicles. This is a cutting edge area in aerospace, and we are fortunate to have joined by two experts in this field who are going to share their insights on this topic. First, we have Jan from Advanced Rotorcraft Technologies, or ART. Jan is an expert in rotorcraft simulations and ART's tools like FLIGHTLAB and RCAS, which are well known in the industry for their advanced capabilities to model aeroelastic effects and flight dynamics. And we also have Gautham from GT. Gautham has been deeply involved in supporting our simulation solutions in GT Suite across various industries, including aerospace. So thank you, Jan and Gautham, for joining us today. I'm excited to have you both here and learn from you. So let's begin with brief introductions.
Thank you, Lalit, for the kind introduction. Yeah, as you said, I'm Jan Goericke. I'm a lead simulation engineer at Advanced Rotorcraft Technology. I'm with Advanced Rotorcraft Technology on and off for the last 24 years, and have seen the development of the eVTOL industry as it pertains to our perspective from supporting the industry with modeling and simulation since its inception. So thank you for being here, and looking forward to this discussion.
Thanks again for the invitation, Lalit. I've been at GT for about 8 years now, starting out as an application expert in fluid thermal systems. And then over the last 3 years or so, I've been more of a solutions consultant, where my main role is to work with our customers and potential customers and introduce them to the various solutions that GT has to offer in terms of system simulation. So looking forward to today's podcast.
Great, thanks for the introductions. So to set the stage, let's start with ART. So Jan, can you share a bit about how the origins about ART and the markets you serve and your flagship products like FLIGHTLAB and RCAS?
Yeah, certainly. Thank you for asking. Advanced Rotorcraft Technology, many people may be not aware that we are a very small company. We are located in the San Francisco Bay Area, where we were founded in 1982 by our president, Ronald Duval. And so we started actually on the premises of the NASA Ames area, and we have always been located close to NASA Ames because we are supporting the vertical takeoff and landing industry with our engineering consulting, but then also with our software solutions. And you mentioned, Lalit, RCAS and FLIGHTLAB. These are products that actually originated early in the 80s and have then grown into these two product branches, where RCAS is a code that ART is managing for the US Army, and FLIGHTLAB is our commercial software that supports VTOL modeling and simulation in terms of flight dynamics, control response, handling qualities, structural dynamics, and so on. And so we have a long background in supporting the VTOL community and with our products. And we are a very research-focused organization. That's why we have experts from all different disciplines within the aerospace, especially VTOL design in terms of aerodynamics, flight controls, structural dynamics, and so on. And that enabled us to be relevant for the last 40 years in this industry. So our latest support for VTOL includes a code called viscous vortex particle method. That's needed for describing the very complex air wake of rotorcraft especially VTOLs where we have propulsors close together, where aerodynamic interaction is very important. And I think that's one of the aspects that's very heavily used right now to support this type of new aircraft emerging. And another software that we have developed in support of VTOL is called FLAT. It's an acoustic solver because now we would want to try to operate in urban environments. And so nobody likes noise around their house. And so we want to make sure that we design aircraft that are conducive to the environment where they're operating. And I think acoustics is one of the drivers for design of these aircraft.
Perfect. Yeah, thanks for sharing this. And it's fascinating to see how, with a small team, you have developed such a deep capability to simulate these complex systems. And I'm sure this is all these tools are very valuable for traditional as well as new players in the aerospace industry. And for those who are not familiar with GT Suite, Gautham, can you briefly explain how our multiphysics system simulation platform fits into this aerospace and eVTOL landscape?
Yeah, absolutely. I think, GT Suite, as you mentioned, is a multi-physics simulation tool. So we operate in a variety of domains, physics-based domains at multiple scales. So what that means is, starting from early stage, design of concepts and architectures. GT Suite is used primarily by various vehicle and mobility space designers to look at different propulsion systems, for example, different cooling architectures, thermal management, integrating controls into the system, and really just being able to leverage a single tool, a single model, right from early stage conceptual design to more detailed, deeper predictive design, deeper in the V cycle, going all the way towards the right of the V, where you have more deployment type activities going on, where you want to integrate with controls, make it real time capable, and leverage some of the popular names in the industry today, which includes digital twins and so on. So I think that's the essence of GT. We started out as a physics-based tool. We are now capable of integrating both physics as well as data-driven and hybrid methodologies into a complete solution, system-level solution.
Great, perfect. So even with this a very brief introduction, it is clear that both ART and GT Suite brings powerful capabilities to the table. So can you both talk about how this partnership between ART and GT Suite or GT began, and like the main idea behind doing a coupled simulation?
If you're okay, Gautham, I would like to take the lead on this one.
Absolutely.
You go to trade shows very often, and we all go there, and sometimes you really get overwhelmed with all these trade shows, and you don't see sometimes the necessary benefit of being there all the time. Our partnership is actually one of those stories where you can see the immediate benefit of joining trade shows, especially when it comes to trade shows that are multidisciplinary, where you meet people that are outside of your usual friend group, let's put it that way, or of your research group even. And our companies actually found each other at the Vertical Flight Society annual forum, there's also an exhibition space, and people walked around. And our director of engineering, Matt Husband, happened to go to the Gamma Technology booth and realized that our software FLIGHTLAB was founded on traditional helicopters. We know turboshaft engines very well. We know everything that uses fossil fuel very well, but we don't know anything about electric propulsion. And so Matt got to talk to the person who staffed the booth at Gamma Technology, and we quickly realized, hey, we are actually a natural partnership, because you understand electric propulsion to the same detail as we understand aerodynamics or other effects. And so it was really more like a partnership of like, hey, can we do something together? And if we can do something together, is this something that would actually help our customers? And so it was really very much initiated by engineering interest. We are all engineering by heart. We are passionate about what we are doing. So we really wanted to find like, there's a clear benefit of us working together. And but of course, you have to see what the customer needs. And so we, over the last 3 years, explored exactly that. It's like, okay, it's a natural partnership, but how can we couple our tools so that they are really powerful together and really provide an end-to-end solution to our customers using our softwares in our respective industries. And then the other thing is overcoming the siloed setup in industries as well, right? We don't have to reinvent the wheel in aerospace. This solutions have already been done in the car industry. We can learn from each other. And I think that's why I'm very excited about our partnership over the last 3 years. Gautham, how do you see our partnership?
I completely agree fully well. I think, as you said, we're a natural fit. You have the expertise and the knowledge on some of the more 3D effects, the dynamics that occur in flight for rotorcraft and specific. So this as through our partnership and even working with you over the last few years, I think we've realized quite interestingly how the effects of dynamics and the sort of transient effects that occur should be tightly coupled with the electric propulsion system. There's several interesting I guess, issues or faults or safety margins that we need to account for as aircraft designers, and being able to take this powerful coupled solution together, I think is going to be very valuable for many of our customers.
Yeah, it makes perfect sense to utilize the complementary nature of these tools and combine them in a coupled manner to provide more value to the client. So, like before this coupling or before this partnership, what were the challenges that people were facing with the siloed simulation in the two different subsystems? Can you talk about that a little bit?
Yeah, if I'm allowed to take the lead on this one, from the aerospace perspective, at least what I've seen is a lot of large corporations are usually have siloed organizations where there is an organization who does controls, there's an organization who does aerospace, and we all know that how the industry is fracturing in that. And what that oftentimes means is that one group is exercising a tool for just flight dynamics, flight performance, and then they give their results to the propulsion group and they run their code and get the propulsion results. And then it goes back and forth between those groups, always with all the overhead that is associated with a large corporation. Some of these eVTOL companies already mimicking the big company behavior. Other companies are very dynamic and have not adopted as all, but I see some of them are actually adopting this kind of behavior. And I think it is exciting if you have a new industry, you can also somehow maybe guide the thinking of people, that you can, with all of our tools, we can put them together much earlier in the design process where people traditionally didn't see a benefit of doing that. And Gautham already alluded to it. There's this tight coupling, especially eVTOL companies or eVTOL configuration, I wanted to say, between flight controls and propulsion is much more tightly coupled than we know it from traditional helicopters, from turboshaft engines and so on. So the idea is really to give the customer tools in their hand early on in their design where they can address these high risk items very early, and so overcome this delay of shifting the data between different organization back and forth, and the little kingdom building that comes with this as well. This is my simulation, and I only know this simulation. So I think that's where I got really excited in seeing the tools that GT has to offer.
Yeah, thanks for that insight. Like Gautham, do you want to add anything to that?
Yeah, no, I think the trends that you're seeing in terms of how organizationally different groups are situated. I think we've seen a lot with our experience in the automotive industry as well. I think being GT being largely a powertrain solution, there's always been that maybe a little bit of difference with the vehicle dynamics or the MBD portion of the organization, and as a system level solution, we've tried to bridge that gap quite well, and we've seen a lot of success with several of our automotive based customers, where providing a platform that allows these different groups and teams with different priorities to sort of work in the same sort of tool set is, I think, quite valuable. I think, we're seeing it now in partnership with ART. The need to bring the airframe and the powertrain solutions together. It's becoming more and more important. We've seen a lot of changes recently. I think even in the auto industry, for example, there's been a lot of rise and plateauing of electrification, which I think is also slightly being reflected in the aero industry today. I think many players in this market went all in on fully electric vertical takeoff and landing. Now we're seeing a little bit more of maybe hybrid and fuel cell and all of these other different propulsion architectures. So because we're basically powertrain agnostic in the sense that we've started out with engines. We're able to handle different electric propulsion devices, and being able to leverage that base along with the flight dynamics and controls, I think is going to be a powerful solution for our customers.
With that context in mind, and you already started covering some of those topics, like I want to explore how the aerospace industry has evolved over the years, particularly with electrified propulsion and eVTOLs.
Yeah, so this is a very interesting question, actually, because I'm now about 25 years in this business, so I have a little bit of a span of looking at the aerospace industry. And what came to my mind immediately after this question is that the aerospace industry has actually not changed, and that's actually the good news for the customer and the frustrating news for the young engineer. Safety is our backbone at aerospace. Electric car, if the motor stops, you just roll on the side of the road and you're usually safe. It's a different outcome with eVTOLs. So I think in that regard, the aerospace industry has always been a little bit on the conservative side, to the frustration of a younger Jan earlier in his career. So it can be very frustrating and sometimes tedious to really do changes in the industry. But having said that, it is a very exciting time because we are now opening up new paradigms. Like we have, when I started at Advanced Rotorcraft Technology, every helicopter had 2 rotors. They might be in different configuration, but every helicopter had 2 rotors, and that was it. And then all of a sudden now eVTOL comes around, and we can distribute the propulsion, and with that we have a huge shift in what we can do with aircraft. You can really, the controls look different, the safety looks different, the customer application look different. However, this is new technology that we have to understand in the context of safety. So if we can transfer all the knowledge that we have from commercial airliners, from traditional helicopters over to eVTOLs in terms of safety to the customer, so that grandma can fly to Thanksgiving with her grandchild in the urban air environment and doesn't even think twice about, is this really safe because it's brand new? That's where we want to go as an industry. And I think that is also one of the other motivations that we have talked about with our collaboration. If you get everything up front, all the simulation, you can do all the fault and failure modes up front in the simulation. You can actually learn very quickly about your system and fit into this safety environment. So I don't think it's the answer that you were looking for. It is a little bit, I'm changing my look on a VTOL industry. I love all the technical challenges with it, but I want to get back to the normal pace of how we design aircraft to make it really a solid solution for our customers in the future.
It's very interesting that you mentioned the safety aspect, because you took the case of an electric motor in a road vehicle, but I think the main challenge for road vehicles is actually the battery, where you have the batteries exploding, and there's a lot of thermal runaway type effects, and I think that becomes even more important in a sort of a new paradigm of electrified propulsion, where batteries are now a key component, sort of the heart of the flying vehicle, and being able to accommodate, keep the battery cool firstly through different thermal management solutions, and incorporating also battery controls and BTMS type applications. I think it's will present unique challenges, and hopefully, that's a good sign for aircraft designers because it's something new that they have to tackle, and they have a lot of maybe the auto industry is a little bit ahead of the curve in this space, having started the electrification path a little bit earlier, but it's certainly an interesting area, and I think that's what excites me about this.
Gautham, I think you basically underlined why our collaboration is so important and fun, right? Because I'm learning in this podcast from you. So this is really it, because you know already stuff that comes down the road. I have not dealt with electropropulsion in detail as much. So I think that is really the showcasing what we experienced in the last 3 years. I learn new stuff, and hopefully you do too. So it's really fun.
Absolutely.
Yeah, so thanks for sharing these interesting perspectives, and we talked about some of the challenges, and I'm sure that these challenges are opening up new opportunities for modeling and simulation. So, Gautam, how do you see the role of the virtual engineering, the simulation, and these tools in driving these innovations in aerospace industry?
That's a great question. I think, aerospace is unique. There's definitely some unique considerations that you need to take into account. I think, so one thing that I've actually learned from Jan, and of course, which is obvious now that I think about it, but it's actually a pretty important detail, is how weight is an important consideration for aircraft. So being able to minimize the weight that goes into all of the components, being able to carry passengers. I think there's a lot of those considerations that are more unique towards the aerospace industry compared to maybe automotive. There's different duty cycles, I think, involved, which in a typical mission profile, I think for a rotorcraft, you have maybe a hover condition, which I think we'll talk a little bit about a little later into the podcast, which is maybe slightly different compared to automotive again, where the hover period has a higher power demand essentially, and it can cause a lot of interesting effects, both from a dynamics perspective as well as propulsion based. Um, there's different environmental conditions, going up in the air versus being on the road. I think there's different humidities, different temperatures, um, various such pressure differentials to take into account, which will sort of influence the performance and the behavior of an aircraft. So I think there's certainly uh, a lot of interesting considerations which I've learned as part of this collaboration, and of course tying it all back towards safety and fault detection, being able to analyze what the impact of a particular fault might be on the end goal, which is the safe delivery of passengers or goods or whatever it is the application is going to be quite important. The cost of being wrong is quite a lot worse. So
Yeah, I think safety is very critical and the most important aspect of the design here. So Jan, can you elaborate how the tools like FLIGHTLAB and RCAS are solving these challenges or helping customers solve these challenges?
I would love to, but right now we are in the exploration phase. We're really looking into what can we offer to the customer, and the customer has to decide themselves. And the customer here is really the OEM, right? The OEM right now, the eVTOL environment is a little bit different than traditional VTOL companies, because they all have a very stringent timeline. eVTOL companies usually operate much faster, have to be much faster to the market, and push very aggressively in the design, which makes it a lot of fun, but it's also, you have to sometimes roll it back, right? But they also push forward in designing their own tools for simulations. So we are still in the exploration phase with Gamma Technology, and I think we have shown on a few occasions, especially in 2024, to our customers how we envision this tool to be used. And I think that's where your question goes into. And what we found is that simulating maneuvering flight early on in design has actually a benefit for these type of aircraft, because traditionally we looked into steady state, and then this kind of siloed simulation is actually still possible, right? You collect your propulsion requirements, and then run it through the propulsion code, and then feed back into the design process of the flight simulation. Nowadays, we found that if we can bring on maneuvering flight early on, and Gautham alluded to that, but especially around hover, what happens when you actually approach a rooftop and to hover, and you fly through a turbulent airway? How does the collaboration between electric propulsion system and flight control system works in order to derive some requirements for the design of these systems? And we found that a coupled simulation that we propose using our tools together actually brings a lot of this knowledge up front in the design process. And that has a positive effect because later on in design, it's really hard to change things in the aircraft. So if we can bring it into the hands of the engineer early on, they can explore what are the crucial aspects of their design in terms, as Gautham said, weight is important, volume is important. And as I learned from Gautham, cooling is important too. And hover is one of those places where you generate a lot of power. This is usually one of the highest power demands in the entire flight envelope. But you also don't have much airstream over your cooling vanes or whatever you think of you'd use for cooling. So there is a lot of things that you can do up front to size your aircraft correctly in terms of weight, weight distribution in the aircraft. But then we also expanded and found that you can look into failure modes, and that's again, it goes back to aircraft sizing, right? What kind of electric components do I have to carry so I can afford to have a failure in one of the rotors? Because now I have like 18, 20 rotors, maybe. What is that an issue? Is it not an issue? What happens to flight safety? What happens to controllability of the aircraft? And so on, because these are operational environments for these small aircraft that are kind of challenging. And so I'm really excited, as you can tell how fast I talk, about the opportunities that we get with doing this coupled simulation where I previously, as a traditional VTOL designer, would have not done that because you can do that after the fact. You know that turboshaft engines, how they react to torque challenges and all that kind of stuff in shipboard landing operations. We have done that for over 20 years with helicopters. eVTOLs are different enough to make it necessary to look into that in more detail. And I find, and I hope our customers do that too, that a coupled simulation gives us a lot of this kind of insight early on in the design space.
Yeah, I think when Jan mentioned thermal management, that reminds me of an important sort of analogy in automotive where, because of this, the move towards electrification, we're seeing considerations that we didn't have to think about maybe with traditional engine-based vehicles, right? Things like range, for example, being able to maximize range in an electrified vertical takeoff landing type aircraft while minimizing the weight, for example, of your battery pack. Obviously, as your battery pack size sort of increases, the more capacity it has, and the longer you can run it. And as we just spoke about, I think weight is an important consideration to minimize in this very interesting optimization problem. So I think that becomes an interesting area to explore and a challenge, depending on what sort of application you're going for, whether it's urban air mobility versus regional air mobility and those sort of interesting factors. With regards to range specifically, that reminded me of other energy consumption aspects in the aircraft. For example, your thermal management system is picking up heat from the various components like your batteries, your inverters, your motors, which are all generating heat in the system. You don't have an engine anymore, so it becomes important to cool the cabin as well. So for passengers, especially when you're transporting passengers, they have to be comfortable in an aircraft. Otherwise, it becomes a question of not being a popular way to travel, let's say. So it's interesting to sort of consider all of this. I think NVH or noise is something you also mentioned, Jan, that is another challenge. You have rotors that are creating noise. You have you no longer have an engine to mask some of that noise, maybe. So it becomes interesting both in terms of components, but also the dynamics and under critical aspects of the flight phase, like hover and so on.
There are lots of complexities involved here for with different subsystems, and for a newcomer or new engineer or new startups or teams trying to or thinking about trying these tools, it could be very overwhelming. So, Jan, like how do you help these new players navigate these steep learning curves in utilizing these tools to solve their problems?
Ali, that is a really good question. It was a really big challenge actually in the beginning of this industry because, as I mentioned, I come from the traditional VTOL industry, which is a very lockstep kind of methodology driven industry because it has like very stringent safety requirements in mind. Versus eVTOL in the beginning was very much research oriented because this is really new. Nobody knew how to design an aircraft like that, and that's why you see all these eVTOL configuration look different. Because they have different applications, different strengths and weaknesses. And so there was a lot of this new pioneer spirit involved in that. And as an aerospace engineer, that's exactly why I am an aerospace engineer, is this passion of making something fly is super cool. What it means in our tools means that there is no time for some new engineer to learn a simulation software for a year before the simulation software can produce some meaningful results in the design of the aircraft. That was acceptable before because we had larger organizations. You can bring people on board, they can learn a tool, they can learn from their peers and their mentors, and then get dangerous in the mid-career stage. Nowadays, it's all front-loaded, right? So you have users that use our software and want to create results next month. That sounds reasonable, but if you know the scientific software, it's usually not quite like that quick. And the CFD is the best example. Try to get a CFD result within a month, everybody will laugh at you, right? And this is very much the same. So our challenge was like, how can we make our product available to our customer in this kind of stringent requirement where you say, okay, it takes some time to learn this tool, especially to understand the results, because simulation, you cannot believe the results of the simulation right away. You have to understand the constraints, the basic assumptions in the simulation, and then you can evaluate the results and use them for your design. So you always have to have good knowledge of what the simulation is actually doing. And so what we have done at ART is we basically provided our new eVTOL customer with the choice of us helping them in the beginning. We would create models for them, and then use those models to train the new team, and then create results very quickly. So the design process would have already some results that they can work forward in the aircraft design while the team is coming on board and understanding how to use the software. And then it's a natural handover. Once the organization understands how to use this tool, then our company would take the hands off and say, okay, now you are in charge and you call us when you need us. And I think that really helped to sustain these kind of aggressive schedules, right? A lot of the eVTOL companies in the beginning are startup companies. Startup companies have natural financial cycles. And it's our responsibility as tool makers to support these cycles, because if there's no money, nobody gets to play. And so we understood this at ART very quickly. And that's why we found if we can cooperate with these companies early on, bring them on board, and make them basically aware of how to use this software and where the pitfalls are. You know, you have to understand the modeling assumptions in order to really get reliable results. And I think that worked with a large group of our customers. And of course, there's customers who can just take it and run with it. So there's a wide range between those as well. So very exciting, actually, in terms of supporting our customers, because we really widened our perspective of, first of all, of how to onboard a software like FLIGHTLAB, and then also how to make it useful right away so you get through the next financial milestone in your organization. Gautham, what's your experience with this crazy industry?
You hit the nail on the head with one of the points, which is to sort of helping them pick up a new tool maybe, or make the transition towards building things from a system simulation mindset, but taking into consideration all of these other factors, sort of bridging the gap between different siloed organizations. I think we've tried to enable that by showing them what's possible and working closely with them and helping build models and laying out the framework so that they can become independent. I think GT Suite was designed about 30 years ago now with the mindset that anyone can really pick it up very quickly. It's a template-based environment. There's a lot of built-in documentation to keep you independent and be able to build these models very quickly. So there's like an electric motor template, for example, that you can simply drag and drop onto the map and build this out very quickly. I think the one of the maybe underrated aspects of the tool is being able to parameterize a lot of the geometrical inputs that go in, a lot of the operating conditions and initial conditions and things like that that you can then use to sweep across different different mission profiles, different operating conditions. I think that's being able to use a single model and leverage that capability is quite powerful. And lastly, I think we've tried to keep the environment in a sort of a robust way where you have subsystems and creating your own sort of customized templates as well with a lot of basic building blocks so that you don't have to worry about, for example, a pipe. I think it's a well proven out solution in terms of predicting pressure drop and temperature rise and things like that that the designer doesn't have to worry about. I think we try to minimize the software development aspect of the design product development cycle and allowing them to focus on the engineering. I think that's another key aspect that I want to highlight, and being able to use the same model across the design cycle, whether it's lower fidelity in early stages versus higher fidelity deeper in the weeks.
And to add to that, I think we also have training classes, webinars, and GT University to help customers onboard and learn these tools. And in fact, Gautham was the instructor for the first training class that I did here at GT. And I was hooked on to this tool, and I learned how generalized and intuitive it is. So that's good. So now shifting gears a little bit, certification is another critical area. So maybe let's explore a little bit about that. I want to learn, I'm curious how the certification process looks like and why it is very challenging to get these eVTOL certified.
Well, Lalit, we haven't talked about some of the big elephants in the room, right? We haven't talked about much about range, because I think range we kind of understand now how to tackle it. Gautham mentioned before, we know that maybe battery only is not good enough, and we might have to have hybrid electric. That kind of solutions are actually out there. So nobody talks about range that much anymore, like maybe 7 years ago. But certification is a really big subject right now, because what I see from in the industry is really, really exciting, actually, right? So we are out of this stage where we research, and now we're getting in the less fun part where we just have to prove to somebody that this is a safe aircraft. And that's really tedious, and it's very structured, and it's highly regulated. Again, I don't want to beat the same drum over and over, but safety is our bread and butter, right? If those things fall down, nobody is happy, especially the people on board. So that's why certification is such a important point right now. In 2024, I think we see big players being very much involved in certification. And what is new for eVTOLs is that these configurations, nobody has ever certified these configurations. So there's some things between a fixed wing and a helicopter. They're neither that nor this. And so it's the FAA, EASA, and other organizations around the world are actually now working with OEMs to define these regulations of how do you design this aircraft. And what I see is really exciting, and what has been done for commercial airliners for a really long time is simulation is considered to be acceptable as a means of compliance, of show compliance to certification. If this really comes through, that of course helps a lot of the eVTOL customers with their desire for the fast cycles, and also to reduce cost. And so this is a really good time for our teams to be involved in this kind of certification, again, to provide tools that may be used through certification in order to shorten a little bit the timeline, and expand the predictions of what you can't do with flight tests. You can't fly all environmental conditions, as Gautham mentioned before. You can't fly all turbulent environments in the real aircraft. So some of that stuff can be done in simulation to show that these aircraft are really safe in all of these environments and can be certified for operations. So I see that tools, simulation tools that are easy to use and fit into an overall certification framework could be very attractive in, right now or in the near future. And what I learned, because I was very honored to participate in the SAE G35 group, where we talked about standards of certifying the advanced air mobility aircraft. You have to think outside the box, but you have to also see the overall picture. So I'm a simulation guy. I really understand simulation, but this has to put into framework of doors. Like you have to track your requirements, you have to track your model properties, you have to track where you got the model properties from wind tunnel testing, your basic engineering assumptions, flight test data. All of that has to be tracked throughout the entire certification process. So it's not just running our codes together and saying, hey, hooray, look at this, we color between the lines, we are awesome. Now there's a huge process of bookkeeping your results, of really showing providence of where you got the assumptions and the modeling. And I think this is really important. And I'm looking forward to creating a tool that can support this kind of stuff, where it's, the challenge here is that every OEM does certification differently. So you have to be flexible to, it's not doors, it's a different tool that's used for tracking requirements. But the overall framework is always the same. You have to be flexible enough to fit into a more structured environment than before. And I think that's a huge challenge because I'm still learning of how certification is done. And this is a really difficult subject because it's not engineering work. It's really very regulatory. You have to understand regulatory language. You have to understand the assumptions and the requirements that come from a regulatory perspective, which is a little bit different to our engineering work. And so I think, again, fun times, I think, ahead. Gautham, what do you think?
Absolutely. I think we've seen a little bit of a different aspect of maybe certification or vehicle verification validation from the automotive perspective. So it's interesting to hear about what sort of challenges I think and how simulation can help drive certification. I think that's very exciting. I think we've helped customers, and one example that comes to mind is again with batteries, right? Taking the concept of electrification here. With batteries, there's complex effects that are happening. It's not just performance or range, like you said. That's important. It's also taking into account effects like aging. I think that's something that we've explored in our collaborations in the past as well, where depending on the duty cycle or the portion of the mission profile, your battery can maybe age a little bit faster, or whether there's reversible or irreversible effects, things like lithium plating or SEI layer formation and things like that are quite important and critical. I think in terms of also advising or giving the industry our perspective a little bit on considering these sort of important effects. Also as you go through the certification process, it's very important not again to be siloed into your own space. I think being there to sort of advise these groups and how that's such a tightly coupled problem, and that it needs to be analyzed in that sort of a way to help certify the right battery pack or the right battery chemistry, for example, for your needs, I think is very important. All coming back to safety again.
Lalit, if I can chime in on this. Gautham, I actually learned something when I went to the Gamma Technology Conference in November or October in Detroit. And thank you for the invitation, actually. That was that we don't have to reinvent the wheel just because we do aircraft certification. I would love to learn what car industry has already been doing, because I know they have requirements too that need to be certified, from that perspective. So I really enjoy this collaboration because I'm not stuck in aerospace. I can see what other industries are doing and can use those tools and approaches already that have been proven for a long time, and with a thorough software in the background. So that was a really good experience, and I think it really speaks to why our teams are so excited to collaborate, is because we don't have to be, oh, you're an aerospace guy, you're a car guy. We are engineers, right? We can design either thing, but what we don't have to do, we don't have to reinvent the wheel over and over and over again because we are so special. No, we aren't. If we peel it back into what the workflow is, we can really learn from each other, and then we can use our tools in conjunction. We don't have to at ART develop another requirements traceability tool, for instance, or something like that. Gamma Technology has already done a lot of that homework in their software.
Yeah, absolutely. I think, likewise, thank you again for presenting at our conference. I think that was well received and interesting, again, topic for our automotive customer base in Detroit. But yeah, I think, we've learned a lot. And speaking of not reinventing the wheel, also, not having to, go down the path of looking at flight dynamics, for example, and flight controls, right? I think you have a lot of experience, 40 years in the industry. I think that's what's exciting for me personally in this partnership, being able to leverage the tools together. And now that we have a proven, I think, framework and an easy deliverable for our customers to take advantage of in this coupled simulation, I think it's going to be very exciting going forward.
Thanks for these insights, and I will link the description about the presentation that Jan delivered at our conference for our viewers. I think the final question for me is, what's your take on what is the real and what is just hyped in this industry, especially for eVTOL? So if you can share your perspective on the reality versus hype, that would be great for our listeners.
That's a really interesting question, and you never saw off the branch of a tree that you're sitting on. So we have to keep that in mind, right? So what is real, what is hype? We really don't know, because we are the tool makers. We make the tools that our customer need, and I don't want to really go and judge on any of these activities from that perspective. But I think what you're asking, Lalit, is really how does it meet reality? And so basically, as a continuation of your question, is like, okay, we let's see, we're going through certification, we have these aircraft, and they meet the real environment. And I think at the conference that I'm attending, you see a lot of very smart people put their heads together of how do these eVTOL aircraft fit into the actual world that is existing right now in a national airspace? How do we integrate 2,000 urban air mobility vehicles into our airspace that's already congested? How do we charge them? How do passengers get to the aircraft and back from the aircraft in the airfield? Do they have to go through TSA, on the rooftop in San Francisco, or do they not? I think there's a lot of really interesting challenges to this industry once you go beyond the engineering fun of designing these aircraft and making them safe to fly. So you have to really think about all these operational aspects. And I actually feel that we are again asked to, with our tools, to help, right? Vertiport design is one of those things that is on my radar. I have seen those designs when I joined the Uber Elevate conferences early on in 2018-19 timeframe. Beautiful structures. But then if you see it from an aerodynamicist perspective, a lot of turbulent air is generated by these beautiful structures, and it's not really fun to land in this kind of turbulent air environment. So there will be a give and take, and I think we are, as tool makers, are again asked to provide tools to help all these operational aspects. Gautham, you talked about charging cycles. So what does it look like if you have an aircraft come in, charge quickly, and then take off again? How quickly can that be done? How often can it be done before the battery ages, so it has to be exchanged? All these operational aspects are really important. And then I think you again, Gamma Technology, are in a very good position to understand what does the maintenance look like for electric propulsion. So we can look into this kind of operations as well. So hype versus reality. I think reality is happening no matter what. I mentioned conservative aerospace industry is always upfront with reality to really for a new engineer, sometimes a very disencouraging level, but it's necessary. And so hype, I think I learned from the Uber Elevate conferences, and I think we can freely talk about them because they basically were absorbed by Joby and are not out there with their conference anymore. There was a lot of hype at the time. 2018, 2019, we were saying, okay, we are flying in 2020. But I understand now that this hype, Mark Moore was one of those really early pioneers who really brought everybody together, got everybody hyped up. But this hype really created something that we did not think was possible. You know, it really got everybody on the table. It created some benchmark designs that we could everybody chew on as a tool maker. It got the entire community to focus and shift focus in the research and development of our tools. I think hype is good. Reality comes in no matter what, you know. I actually really learned a lot in the last 7 years because, as I mentioned before, every helicopter had 2 rotors. So now I have a fully new perspective, and that's something awesome for a 50-year-old engineer to still like get the passion and get the ideas flowing. And I hope you guys at GT see it the same way. It's like, yes, there's not obviously immediate riches that we all need to generate for our shareholders, but there is a lot to be learned, and a lot of cool progress is made in research and development to make this all possible in the future. And I'm really excited. So I hope it's not all hype.
No, I think you're very right, and that hype is needed. I think we all need those visionaries, those innovators, those folks who want to shoot for the moon and make it happen in the same decade. So I think we're fortunate to be part of, I think, humanity in general. I think we haven't lost that
Very good point.
that feeling of achieving the impossible. So I think it's exciting times. For sure, maybe not going to the moon in this case, but bringing I think affordable and maybe hopefully less congested roads for people to travel going forward. So it's a interesting and a fun endeavor for sure to be on the engineering side of things.
And if I'm allowed, I just want to bring everything back to our collaboration because I just want everybody to know how much I enjoyed that. I guess is we really found each other in the same kind of mindset. We are research forward. You know, we see our customer needs and we want to create something that is useful. So
Absolutely.
Both of our companies don't feel pleasure in just selling licenses or our software. We want to sell solutions. And I think that is my motivation every day, is that I want to make my tool more useful to a customer, that I can tell later my daughter, somewhere on this aircraft, my software has been used. So, hey, there's my glory there, and this kind of, so this is one of the drivers. And I think it's very great to find another company who has the same kind of mindset. We are not really bottom line, how much profit are we making on that oriented. We are really research forward, and I think that is the exciting part in this one. And I feel, quite honestly, I've worked in large corporations before. Those kind of corporations are usually the successful one at the end of the day, because customers pick up on this kind of energy. As you said, it's good to be a human. I really like that phrase. I will keep that in mind. Yes, it truly is. And if you find like-minded humans in your quest, it's always more enjoyable.
So it's a great summary of the conversation, Jan, and thank you, Gautham, for mentioning all those points. It's a good point to conclude the conversation here. This has been such an insightful and enlightening conversation for me. I learned so much. So thank you, Jan and Gautham, for sharing your expertise and for giving our listeners a deeper understanding of how GT and ART are shaping the eVTOL industry and supporting innovations in the aerospace industry. Thank you again for your time, and to our audience, thank you for tuning in. And if you have any questions, feel free to reach out, and don't forget to subscribe for more episodes on simulation, technology, and engineering. So until next time, take care. Thank you.